It's a privilege and an honor to be here and to talk about this book that Bettina and I wrote. It's also, of course, as Dr. Kearns, and thank you for that introduction, mentioned, it's an auspicious time. We're having this weekend, it is the 75th anniversary of the experiment conducted in the ancestor of Argonne Laboratory, an experiment that changed our world. Yesterday was also, I might mention, the 63rd anniversary of the death of Enrico Fermi, who died tragically at age 53. So who was Enrico Fermi? Well, I was born in Italy, so I can say a few things from the viewpoint of an Italian. He was the greatest, first of all, he was the greatest Italian scientist since Galileo. He was also one of the very greatest physicists of the 20th century. But in being one of the greatest, he was also unique in several aspects. One of them is that he was self-taught. Physics in Italy was backward at the time he was growing up, so he learned physics by reading books in French, German, English, and he taught himself physics. And in doing so, he developed his own style. Again, a unique feature. And part of that style was he regarded physics as a whole, theory and experiment. And at a young age, he decided that he had to be both. He started conducting experiments when in his teens, while he was reading these books on mathematics, and that's a thread that runs through his life. He was the only one of the great physicists of the 20th century to be great as both a theorist and an experimentalist. And he also felt that he had to know all of physics. Everything from relativity to nuclei and so on. And so I think one can honestly say that he was the last person who knew all of physics. Now, of course, that's impossible now, but frankly, I think it was impossible then as well, you know. There's something amazing about him. So here, what I've done is put on the first slide, and I'm going to talk for a while, then Bettina will take over. Some of the experiments he conducted. Now, of course, one of the things we talk about, let's see, I'm looking at my laser, Well, I don't seem to be working the laser pointer very well.
It's the top button.
Thank you, Bettina. That's what we call cooperation.
Can I leave now? It's my contribution.
So this is the pile. CP1 is the thing we will be talking about today. But as you see, he worked in all fields. And in fact, as an undergraduate, I know we have a great X-ray source here. His undergraduate thesis was on building better lenses for X-rays. And the last experiments he conducted were on the synchrocyclotron built with him in mind at the University of Chicago. And in between, we have everything else, neutron scattering, Raman scattering, etc. Including some devices. He also loved gadgets. In his office at the University of Chicago, he insisted that next door, they built him a little laboratory with saws and et cetera, that he could go in and play with and build little things such as the Fermi trolley. So here's some of his experimental work. Here's some of his theoretical work. I'm sorry.
You were right.
I'm trying to do, I went backwards. I showed experiments first, and this is some of the theories. As I said, as an undergraduate, he already was writing groundbreaking papers on relativity. Then a subject practically unknown in Italy, and in large part in the world, we're talking about 1919, 1920, there are still the so-called Fermi coordinates are used in general relativity. So everything from that to his pioneering work with computers. And in between, we see a little bit of everything else, including in particular the work on slow neutrons. But if this was only a physics talk, you might find it a little too technical. So we're going to talk about some of the other issues that impinged on his life. And his first interest and main interest was always physics, but he lived through trying times, and this includes the rise of fascism in Italy, the need to emigrate, the development of the bomb, the post-war years in the United States, including the development of the hydrogen bomb. By the way, I might mention, Fermi was always full of ideas. The idea for the hydrogen bomb originated with a casual lunch he had with Teller in 1941. What he said basically to Teller was, you know, if we could develop an atom bomb, we could use that as a trigger for the type of reaction that occurs inside the sun. Interesting idea, isn't it? Teller went away. Fermi didn't think much about it, but for Teller it became, as we know, a lifelong obsession. So, this is the man's work, and the issues that are raised by his life are issues that are very much still with us today. One is the question of emigration. He emigrated in the United States in 1938, largely because his wife was Jewish. They needed to flee Italy at the time. Racial laws had just been passed. The issue of nuclear war and nuclear threats is, of course, very much with us still today. In Italy at the time, in 1945, there was one nation having a nuclear weapon. Now there are 10, and nuclear weapons are in the hands sometimes of people we do not have full confidence in. Science and public policy. In making decisions, are the scientists in the government advising, as they were in 1945, or are they outside the government? All these issues are raised in the book as we wrote it. But let's turn back to the book for a moment. Here it is. It's just come out in Italian as well. And there are some personal reasons for writing the book. One, of course, is that the issues I just raised. Another is that I was born in Italy, came to the United States as a baby, went back to Italy in 1947, and grew up there until I went to college. And for that, I came back to the United States. But growing up in Italy, if you wanted to be a scientist, or you thought about being a scientist, what do you really think about when you're 13 or 14? Except, of course, Fermi, who had already decided he wanted to be a physicist. So I thought I wanted to be a scientist, and Fermi was a hero in Italy. He was also a hero because he seemed so ordinary. He looked like an ordinary Italian. And I thought, boy, maybe I too can become a physicist. There's a personal connection in that I have an uncle, Emilio, And Emilio Segrè has done very well. He got a Nobel Prize in physics, etc. But he owes his career to Fermi. In 1927, when Fermi became a professor in Rome, he was Italy's first professor of theoretical physics. There were no physics students. So they went over to the engineering school, looked for the third-year engineering students, and said, "We just hired a physicist here. This is an opportunity. You kids have never heard about quantum mechanics and all that stuff, quantum theory. But we just hired somebody who's really smart. Anybody want to transfer from engineering to physics?" So my uncle raised his hand and became Fermi's first student. Now, my uncle was reasonably smart and so on, and would have been quite a good engineer, I think. But instead, he became a very good physicist by staying very close to Fermi for many, many years and being trained by him. Fermi, by the way, was a fabulous teacher, and we will talk more about that. But Bettina has a personal connection to Fermi as well.
So, you can only survive writing a book with your husband if you keep your sense of humor. And one of the things that happened was Gino kept on saying, well, you know, my family was friends with Fermi through my uncle, et cetera. I met Fermi when I was 2. And I reminded him that I met Fermi when I was 13. I think that counts for a lot more, don't you think? And this was in Los Alamos. I grew up in the Atomic City, and Fermi, although my family came after the war, Fermi came back summers to Los Alamos often, and in the European tradition that had been established, the scientists at Los Alamos would go on Sunday hikes. Do you all go on Sunday hikes here? Anyway, so I see some heads nodding. Good. So Fermi was on some of those hikes. My father was a serious mountaineer, had climbed in the Himalayas, etc. He was a better climber than Fermi, but he wasn't a better physicist. And Fermi, among the people on those hikes, to me, as a teenager, I thought he seemed quite normal. That was very nice for a teenager. Teenagers like normal. Maybe today's teens like it a little bit more edgy, but that time they liked it normal. And I remember Fermi sharing an orange with me and thinking that was really a nice thing to do. So he came across as this very nice person. So that's my own history with Fermi. The other part of it is we have some background history. As Gino mentioned, Fermi came over. They left, actually, Europe in 1938. In December. They arrived in the United States January 2nd, 1939. Gino's family, similarly, Fermi's wife was Jewish. Gino's family, similarly, had immigrated from Italy in 1939, and his father was Jewish, his mother was not. My family had left Germany in 1938. My mother was Jewish, my father was not. So those bonds of fleeing fascism, of fleeing anti-Semitism, was something that I think attracted us both to Fermi. So where did this genius come from? How did this happen that this genius was born in 1901, in Italy? And here are his parents. His parents were aspiring middle class. His father worked for the railroad. His mother was a teacher. They did not have university degrees. They had 3 children. Whoops, why is this doing this? Okay, they're there. 3 children, one after another. And by the time young Enrico came along in the middle there, his mother said, well, I really want a teaching career. And I think we need to farm this child out. And they literally farmed the child out. That Enrico was brought to a family in the country, and that family brought him up for 2.5 years in the country. And this is the way she dealt with 3 children in such quick succession. When he came back to join his family at age 2.5 in Rome, he did something that I think is very natural for a child to do. He burst into tears. Here were these two parents, these two siblings. He burst into tears. An apartment, where were the cows? And his mother said, in that lovely supporting way that mothers can be, "Stop that immediately. We will have none of that." Now, I will attribute that to how Fermi developed, because he learned in that way to control his emotions. He was a man who did control his emotions throughout his life. He was not an automaton. He had a great sense of humor, etc., but he was very controlled in his emotions, and I date it back to that incident at 2.5 years, when he was 2.5 years old. He also started getting, not at 2.5, but later on, interested in science, to retreat in a way to a rational world of science, a world that isn't known for being full of emotions. And he, as Gino described, got his hands on everything he could do, get his hands on in science, in mathematics, etc. For example, Campo di Fiori in Rome. This, probably you've been there. It's a wonderful marketplace in the middle of Rome. It still exists. And as a child, he would go there. As a teenager, he would go there. And he would not get gelato. He would get books. And there's one book that he got when he was 14. It was written in 1830. It had 900 pages. It was all about science and math, and it was written by a priest in Latin, and he devoured it. This gives you some sense of how driven he was in terms of science. He was not recognized as a genius by his family, but a family friend luckily said, "Yeah, I think you have a pretty smart kid here. Why don't you see whether he can compete to get into the elite school in Italy that was associated with University of Pisa, the college, and that was the Scuola Normale. And the Scuola Normale, to do that, which Fermi did, was a 3-day exam at age 16 to get into that, being examined about all sorts of knowledge, and he answered one question that was a key physics question, and the physics professor who was on the panel to judge whether students were good enough for the Scuola Normale called him into his office. And I have this image of Fermi quaking, why is this physics professor, distinguished guy, calling me into his office? And the physics professor said, this answer, how did you arrive at this answer? And Fermi had gone way beyond what the question was into all sorts of, maybe during the question and answer today we can go into it more, but all sorts of esoteric things, and explained how he had gotten to the answer. And the physics professor said, "I don't think you will have any trouble," this skips occasionally, do you know that? Getting into the Scuola Normale. And that is the Scuola up there on the right, which was associated with the university. There was only one problem. He was one of 40 people in Italy admitted. He was the only one who was a physics major, incidentally. But nobody at the Scuola or at the university could teach him anything about physics. He knew it all. He had consulted all these journals already. He kept on doing that. He kept on being self-taught. But there was a wonderful side effect of his being admitted, and that was he started having fun. He had grown up in a very austere Italian family. His mother was in basically a clinical depression most of the time. And he got to the university and he started making friends. Rossetti becomes a friend, very long-term friend. And they went to the mountains together. They went swimming. We have lots of pictures. They went skiing. They played practical jokes. He loved playing practical jokes. And this is really something that he got at the university that was very important for his development. Gino.
You'll have to excuse us for getting these slides. We are using, normally, we have our own advancer, which is an old one, so we really have to push down to go forward a slide, whereas this, I should have known. Argonne has one that's much better. You just touch it. So we may accidentally jump ahead. So here we have a picture of him in the mountains. Here's a picture taken a few years later. He's 26. He's taking an excursion on Lake Como with two other friends, Werner Heisenberg and Wolfgang Pauli. The three of them were already famous. They had done work by the time they were 25 that was certainly of Nobel Prize quality. In fact, it was even better than that. They were revolutionizing physics, so much so that in Germany, physics began to be called Knabenphysik, boys' physics, because these young men were 25, 26. They were all born in the 20th century. Fermi was famous for something we call Fermi statistics, which you know is at the basis of modern electronics and everything up to white dwarf stars. So he's already a famous theorist, but Fermi is Fermi. And physics is physics for Fermi, and that means experiment and theory. So there he is at age 27. He's Italy's first professor of theoretical physics, but he decides he wants to have an experimental program going. So he collects a group of people around him, even younger than he was, and they start doing experiments. They were all young, they were all jolly, and they took nicknames. Now, Fermi being, quote, infallible, and this being Rome, his nickname was Il Papa, the Pope. The person to his right is a friend from Pisa, Rossetti, who was also in the picture in mountain climbing, and Rossetti was the cardinal. Person next to him is Amaldi, the titan of post-war Italian physics. He was known as the fanciullo, the boy. Next, on the end is a chemist, Agostino. The person between them is my uncle. His nickname was Il Basilisco, basilisk, a fire-spitting monster, which says something about my uncle. And I have some family stories to tell afterwards. It may also have been that he was Jewish, so they didn't give him an ecclesiastical nickname. But the seniors, there was one man, Corbino, who looked after them, this sort of founder of the department, the head of it, and they called him affectionately Padre Eterno, God, the Eternal Father. And the man who provided them with a little bit of radium, which they needed for their experiments, was known as the Divine Providence. So with the help of the Eternal Father and the Divine Providence, they started doing experiments. Lots of different atomic physics, Raman scattering, but in 1934, they began the most famous experiment. And this was the scattering of nuclei by neutrons to induce radioactivity. Fermi's theories were simple. His style was very simple, and his experiments were very simple. Here's a picture. You have a little radioactive irradiated source. You put it inside a Geiger counter you've built. You put a lead cylinder around it. You pull it out the Geiger counter. You run down the hall, and you measure the radiation in it. They did this for all the chemicals they could get their hands on. Here's some of the chemicals. This is a picture from the collection in Rome. So here's a sort of set of chemicals. They tried everything from hydrogen to uranium. This is also the papers they wrote are interesting in another way, of course. Aside from the physics, I believe it is the first paper written by 5 physicists. Normally, you had maybe the Herr Professor with a student or a postdoc, and papers typically had 1 or 2, but this was 5. They all participated in every aspect. They took turns doing the different parts of it. They were a jolly bunch. There's another thing that was different about this, that Corbino, when he saw the results, he said to them, you know, my young boys here, the boys of the Japanese, you should take out a patent. They said, a patent? And he says, yes, you know, this irradiation might be useful for medical purposes. So they all got together one evening, right after the experiment, the 5 of them, and they sat around, I think it was Amaldi's living room, and they wrote out both a paper, and then the next day they wrote out a patent application. This, by the way, is there was a friend of theirs who was a physicist who emigrated to America and says, hey, I'll start a business in America. So he filed a patent in America. This is the American patent. Italy, at the time, it had been a backwater. It wasn't a backwater anymore. People started coming from Northern Europe to Rome to see what Il Papa was doing and to learn this new style of physics. There were pilgrimages to the Rome of Via Panisperna, and these are some of the names of the people who came. We put in green the ones that got Nobel Prizes, but you'll notice some of the names like Placek, Bethe, Bloch, Uhlenbeck. Those are not Italian names. Okay. There's one other thing I might mention about this list. 10 years later, many of these people would gather at Los Alamos. There were 3 senior Italian physicists at Los Alamos. They're on this list. Rossi, Fermi, of course, and Segrè. Bethe there was head of the theory division, together with Peierls. Teller was, of course, there, et cetera, et cetera. So Italy was now a mecca of physics. But the physics was the thing not the thing he cared about most, but he certainly cared about it a lot, but there were other things he cared about.
Okay. Well, we almost got to kiss there, but anyway, we'll save that till later. So that's the finale today. So what I get to cover is romance. And there she is, Laura Capone. And in 1926...
I find romance embarrassing. I'm going to sit down.
We'll talk about that later, dear. Anyway, so this is Laura Capone in 1926. He met her while he was vacationing in the Dolomites, as she was. She was there with her family. Her father was a distinguished math professor, is that correct? Was he a math professor? I can't remember. Anyway, she was from an upper middle class family, unlike Fermi, who came from a lower middle class family, and she was Jewish, which Fermi was not. He had been brought up not in a religious family, but he had not been brought up Jewish, and he fell head over heels in love with her. She, on the other hand, was a little hesitant. She wrote to a friend, and she said, I met Fermi today, the hope of Italian physics. He was nice, but he had exceedingly thin and fleshless lips. Now, this was the beginning of a great romance, so there's hope for us all. Sure enough, they got married the next year in Rome. And here's the wedding party, looking quite elegant indeed, I think. And the person that I am drawn to is the gentleman in the white suit with his white hat. And he was Laura's father. And he had been, an admiral in the Italian Navy. That's why Gino was looking at me so strangely. He was an admiral. He was not an academic in the Italian Navy. And in 1928, when this picture was taken, he was Jewish, he had no worries. It is interesting to note 10 years from then, in 1938, he was indeed endangered and in serious trouble in Italy. But in 1928, this was a very happy scene. The next year, Fermi was inducted into the Royal Italian Academy. The Royal Italian Academy was something that Mussolini had concocted. It was a way to show off Italy's best and brightest in the arts and in the sciences. And it was a great honor to be tapped to be part of this. And you can see Fermi right here. And when you were inducted, you got this lovely cape and a hat, a grand hat, and a sword, and you were called Your Excellency, and you were given a major stipend by the Italian government. Now, this was very nice for Fermi because he was on an academic salary, and those are not very generous sometimes. And he wanted Laura to live in the style to which he was accustomed. And this stipend was a significant amount of money, so he welcomed it. In order to do this, on the other hand, he had to become a member of the Fascist Party. So in 1929, he became a member of the Fascist Party. He did so, it wasn't a big deal for him. He thought, well, okay, fine. And let me make a note, because Fermi was very apolitical. He didn't want to get involved in politics. He understood science. He wanted to get involved in science. Science was something he knew his way around. Politics he had no understanding of. And he compartmentalized these worlds very much so, even though fascism was taking hold in Italy. There was fascism and there was science, and Fermi was totally in the science world. Of course, that world got impinged on by politics, by what was happening in society, and continued to be throughout his life. And he, of course, in turn, very much shaped our world. So it wasn't that much of an escape. But here's the family in Rome. I'll get this down. And there's Laura, 2 small children, very happy. Fermi had gone to University of Michigan to teach at a couple of summers, actually more than a couple, about 5 summers, between 1930 and 1937. And he had really liked the United States. Laura had gone with him on one of those trips in 1940, and she really did not like the United States. She was not interested. 1930, thank you. She was not interested in coming to the United States. He was sort of intrigued with this idea because, among other things, American science was taking off, and so many of the scientists from Europe who were fleeing fascism and Nazism were in the United States. It was where things were happening. But she really wanted to be in Rome. She was a child of Rome. Her parents were there. Her friends were there. She was raising children there, and that's where she wanted to be. That all changed, however, in the summer of 1938. This is a picture of Mussolini in May of 38, showing off Italian troops who look very threatening, don't you think, to Hitler. And those ties between Mussolini and Hitler were getting closer and closer. Many in Italy had hoped they wouldn't, but that was not the way it happened. I don't know who this man is, but he does want you to know he's very important. And once those ties started getting closer, the anti-Semitic laws were passed in Italy in the summer of 1938. And Laura, at that point, knew that she was in danger in Italy as well as her children. and there was no choice but to come to the United States. Fermi, in a very clandestine and careful way, as was his wont always, wrote to 5 different universities in the United States and said, I'm interested in a teaching position, etc. And he heard from all 5. They all offered him teaching positions. He took the offer from Columbia. But this was all very secret. And he had a rather, I think, snazzy escape plan in terms of getting out of Italy. And that was that he picked up a Nobel Prize in Stockholm and then came to the United States. Now in Italy they were expecting him back, but he had no intention, having gone there with his family and his kid, with his wife and children, he had no intention of coming back. They were going straight to the United States from there. And the picture on your left shows him, that's Pearl Buck, who got the Nobel Prize in Literature that year. And on the right-hand slide, you see him accepting the prize from the king and bowing before the king. The Italian newspapers, who thought Fermi's allegiance to the fascist party was suspect, really didn't like the fact that he did not wear that beautiful outfit with the cape and the sword, etc., and that he did not give the fascists salute when he got his Nobel Prize. So that's what the Italian newspapers covered deep in the newspaper, not that he had gotten a Nobel Prize, but how he had done it all wrong by insulting Mussolini in doing so. So off they went, and they landed in the United States, as I mentioned, January 2nd, 1939. Looking very pleased indeed. Fermi turned to Laura and says that we have now founded the American branch of the Fermi family. You know?
Thank you. And they had founded that American branch. 2 weeks later, Fermi heard some very surprising news, that is, fission. Fission had been discovered, namely a process now that you all know about, a neutron bombarding a nucleus of uranium. In this case, it's the particular isotope U-235. They didn't realize that at the beginning, but they know a neutron bombarding uranium can, under certain circumstances, cause the nucleus to fission. To fission with a very large release of energy, dwarfing anything on a chemical scale, and furthermore, in that process, additional neutrons will be released. Well, if this is possible, it is, of course, possible to imagine putting more uranium-235 together, and thereby starting a chain reaction. And if you can have a chain reaction of a compact ball, in a compact ball of uranium, you might actually be able to build a bomb. Now, Fermi, of course, was interested in this primarily from the physics point of view, and started doing some experiments at Columbia trying to study the process of fission. A number of scientists, most of them European refugees, were concerned about the possibility of a bomb, and in particular of the Germans developing a bomb. But the United States was still somewhat of the sleeping giant. It was saying, well, that concerns the Europeans. There was not a sense of urgency. So, with rather limited means, Fermi and others conducted these experiments in 1939, 40, and 41, and then something dramatic happened, namely Pearl Harbor, December 7th, 1941, and the United States was in a war. At that point, a new sense of urgency developed, time, not money, was the matter, and the Manhattan Project was begun, and the idea of, as I said, time, not money, was the matter, was the primary focus. And they decided to see if they could have, in the United States, have a self-sustaining nuclear chain reaction could be obtained. The decision was to conduct the experiment in Chicago. Arthur Compton was the overall head of this. Something called the Metallurgical Laboratory was founded. One man was particularly needed. That was Enrico Fermi. Enrico Fermi moved to Chicago. He shuttled back and forth from Columbia to Chicago during the spring of 1942. Then he moved to Chicago. They built bigger and bigger piles, and by the fall, they were ready to conduct the key experiment. It was originally going to be built in the Argonne forest, but they ran into some construction problems, some labor problems, and in November, a decision was made to conduct the experiment in a double squash court under the University of Chicago's football field. Compton was worried, other people were worried if the experiment failed, would this lead to some leakage of radiation? Fermi said, I'll take care of it. Fermi was the Pope. And all right. So they started the construction in November. A team was assembled under the leadership of Walter Zinn to build the pile, and they did it in 2 weeks. In 2 weeks, they assembled almost 1 million pounds of machined 20-pound blocks of graphite. It had about 100,000 pounds of uranium in there. Graphite, or as Fermi, who still had a bit of an Italian accent, we've heard a record, calls it graphite. Okay. There were control rods with cadmium there so that the reaction would not start until everything was ready. The president of the University of Chicago was not told, because if he was told, he would have had to forbid the experiment. And this was a matter of national security. As we know, on December 2nd, 1942, the experiment was finally conducted. There were 49 individuals assembled on the balcony of the squash court. One woman, by the way, you can barely see her here, Leona Marshall. She was also the youngest person there. At a little bit after 3 o'clock in the afternoon, Fermi said, it has gone critical. He ran it then for 25 minutes as the curve that he had predicted was traced. Shortly before 4 o'clock, he announced, zip in, put the rods back in. There was not celebration then, because it was felt everybody knew the gravity of what had just been achieved. This was the future of nuclear reactors and also the future of nuclear weapons. With this, you could build plutonium. You could obtain plutonium, which would be the fuel for nuclear weapons. Eugene Wigner had stashed away, confident that the experiment would work, a fiasco of wine in the corner with some paper cups. He pulled it out. They all took a sip, signed the straw, and then Compton raced to his office to call Conant in Washington to give the coded message, the Italian navigator has landed. Conant said, and were the natives happy? Yes, all were safe and sound. That was CP1. CP1 was then taken apart, rebuilt with shielding in the Argonne forest. And here is CP2. Fermi, physics. When you hear Fermi, think physics. He loved this. He said, you know, he had been working for almost a decade trying to improve his neutron sources. And it had been a struggle. And now he had this marvelous tool. This is his close collaborator, Herbert Anderson, said. What thrilled Fermi most about the chain reacting pile was it was a marvelous experimental tool. So this is CP2. They then began to plan CP3, the heavy water reactor. This came into function in May, finally, of 1944. Fermi had stayed in Chicago. Many physicists had gone to Los Alamos. He did go at times to Los Alamos. He went to Oak Ridge. He went to Hanford, which was being built. But he was needed at CP2 and CP3 to perfect the reactors to see if enough plutonium could be obtained, because this was the model for the giant factory being built at Hanford. Finally, when Hanford went into operation and was running satisfactorily, there's a story about that too, in September 1944, that's when he went to Los Alamos.
Thank you. So, as you well know, Argonne was the cornerstone of the Manhattan Project, but there were 3 secret cities that were built in very, very quickly. One of those was Los Alamos, which is where Fermi ended up going. Can't do it. So there's Los Alamos with its gate where everybody had to show a security pass. There is Nella Fermi at age 13 coming with her family there. And it was a secret community and an amazing enterprise between government, academia, and industry, who are all cooperative and employed over 100,000 people, and it was all secret. I don't think that could happen in today's world. And Los Alamos, which I tell my children that I grew up in the ultimate gated community, meaning Los Alamos, was there in New Mexico on a mesa, and it's a beautiful spot, and it became an army base there. It was quite an ugly city. When Laura Fermi came there, she had been used to sleeping in satin sheets and things like that. She came there, she was given piles of sheets, of blankets, of towels, and they all said in big bold letters, USED, used. And she thought that was rather tacky until somebody pointed out that it stood for the United States Engineering Department. But the Fermi family lived in barracks like this. It was quite primitive. But there was a very intense feeling in Los Alamos that Los Alamos was attempting to get to the bomb before the Germans did. And many of the people in Los Alamos were refugees from Europe, so they had skin in the game, literally, figuratively. Many of them were Jewish, and there was a mission across all of the Manhattan Project, whether it was the Argonne Lab or in Los Alamos, to try to, as much as you can, rush this schedule of getting to building a bomb. Here you have here's Fermi, Richard Feynman, Oppenheimer, some others, and you can see that intensity the average age at Los Alamos was 27. Think about that. Fermi was quite old for that. But in fact, they did accomplish what they had set out to accomplish. And July 16th, 1945, the bomb went off, the first atomic bomb, first time that the mushroom cloud had appeared, this iconic figure, which, by the way, graced my high school yearbook in resplendent colors. And here was the bomb at Trinity site. And when the bomb went off, the scientists observed it from different vantage points. And Oppenheimer, when he saw the mushroom cloud, he, very Oppenheimer-like, quoted from the Sanskrit scriptures and said, now we have become death, the destroyer of worlds. Another physicist that was looking at it from another vantage point, Ken Bainbridge, said in more prosaic terms, now we're all sons of bitches. Fermi was Fermi. Fermi had taken a piece of paper and he had torn it up into little bits. And when the shock wave started coming toward him, he threw these pieces of paper up into the air because he figured where they would land, by where they would land, he could calculate how powerful the bomb was. So he was always rational. He was always trying to figure out. He was always quantitative in what he did. And in fact, the estimation that he gave was closer than anybody else's, and the Pope, as usual, was right. We did visit that site, incidentally, in part of our research, and they today have an obelisk there, and it is one of the more eerie places to visit in New Mexico. It's open 2 times a year, and you go through about 5 gates, and you see nothing but desert. And the significance of what happened there hit me anyway in a very hard way. So shortly after that, the first atomic bomb was dropped. It was dropped on Hiroshima, August 6, 1945, a few days later in Nagasaki. This was not done without controversy within the government. And Gino's point earlier about inside-outside government, there was debate in government about whether we should drop a bomb or whether we should have a demonstration. The latter viewpoint was taken by a physicist named James Frank at the University of Chicago and a group there, saying, we can do a demonstration. If the Japanese, and invite the Japanese, if they see this, the war will end. But the other people said, no, there's no really acceptable alternative. We have to use the bomb because otherwise Japan won't think we are serious. 100,000 people died as a result of this bombing. Now that's equivalent to the firebombing of Tokyo, but it was one bomb, and it was death by a very different, in a very different and prolonged way in many cases. So it was different in that regard.
The war was over, and Fermi wanted to rush back to physics, to doing, he did, of course, all this work, organizing and so on, experiments, both for the Manhattan Project and then at Los Alamos, but he wanted to return to physics pure and simple. So here he is, superimposed, he's rushing along the shores of Lake Michigan, rushing to get back to the gates of the University of Chicago, and rushing to get back to Argonne, to do some more experiments with his beloved CP3 and with his collaborators. And he did that in 1946, 47, 48. And on the next slide, I'm going to show a paper he wrote based on physics, using CP3, the reactor here. But I did want to mention, Fermi was Fermi. It was always theory and experiment. At 15, he's reading math, but he's doing an experiment to measure barometric pressure. At 20, he's writing a paper on general relativity, but he's doing X-ray lenses. In 1934, he discovers the use of slow neutrons, but at the same time, he writes the fundamental paper introducing weak interactions. Fermi said he suffered from a kind of functional insomnia. He would get up at 4:35 in the morning, work for a few hours on theory, and then go into the lab and work on experiments. So in the next slide, this is the last paper he wrote based on an experiment done at Argonne. Argonne by then was founded. Let me remind you, you know. Fermi, Argonne was started in 1946 as the United States' first national laboratory, and its first director was Walter Zinn, the man who had been together with Fermi for years now, since Columbia days, the man who was in charge officially of assembling the pile. So this is an experiment with Leona Marshall, who was also one of the people on the balcony. It's on neutron scattering, neutron-deuteron scattering, but Fermi was Fermi. You'll notice this is in issue 75, 1949. In issue 75, 1949, there's another paper on the theory of cosmic radiation. This is still what's called the Fermi mechanism for accelerating cosmic rays. It is a fundamental theoretical paper on cosmic rays. It was the last experiment he conducted at Argonne because he was also looking for some new frontier now. He had been working with neutrons for 10 years, and he was fascinated by the idea of elementary particles. So, and I went backwards here, and okay. So Chicago had built a synchro cyclotron. So this is what he started doing experiments with. And of course, he was also the great teacher. Chicago, and we're almost finished now, Chicago in the 40s, in the late 40s, was the place to go if you were a physicist. Many people who had worked at Los Alamos came to Chicago with Fermi. People came from all over the world. Fermi was the world's most influential physicist. And people came, as I said, from all over the world. Again, in green, we have some of the Nobel Prize winners. He was also famous as a teacher. Bettina told you the story about throwing the paper in the air. Fermi talked to his students at lunch with them. They invite him to his house in the evening, and he said, physics is simple. You have to start from the beginning, and you have to be able to estimate anything. The dirt on a window, the fires in the fireplace, how high are the flames? How dirty are the windows? When does the dirt start falling? This got to be such a joke almost that in the profession there are now something called Fermi questions. Fermi questions are one of the famous ones. How many piano tuners in Chicago? Who knows how many piano tuners? Well, you start saying how many pianos are there in Chicago? How often do they need to get tuned? How long does it take to tune one, etc. And lo and behold, you know how many piano tuners there are in Chicago, to within a factor of 2. Then you check it in the yellow pages. 1954, Fermi was at the very height of his powers. Here he was holding his eternal slide rule. I brought a slide rule. Many of you who are younger don't know what this is. This is what we used before there were pocket calculators. It's a very clever instrument, and you can approximate things very well. There he is with his slide rule, you see. It fits nicely there. And at the same time, Laura Fermi was writing a book. She wrote a book called Atoms in the Family, My Life with Enrico Fermi. It turned out to be really very good. It was serialized in the New Yorker. It became a bestseller. 1954, in the summer of 1954, things were going very, very well. Their older child was already in college. The younger child just went to college. There was only one thing wrong. During the summer, they went back to Italy, taught at some summer schools, and Fermi had terrible stomach aches. When they went back to Chicago, he had exploratory surgery, and it was found that he had metastatic stomach cancer. He died on November 28th. Bettina, you want to take over?
Sure. November 28th, yesterday, 63 years ago. And again, he treated his imminent death as he treated many things in a totally rational way. He wanted to go home from the hospital to die, and he told Laura, we have to rent a hospital bed, but don't rent it beyond November. He had calculated that in September, and sure enough, he had died on November 28th. The gravestone just says Enrico Fermi, physicist, pure and simple, as he would want to be known. This gravestone is in Oakwood Cemetery in Chicago. I would like to point out another stone, not a gravestone, but another commemorative stone where Argonne was first started, where CP 1, 2, and 3 were known, and where they are buried, 2 and 3 anyway. And finally, another kind of commemoration, and this is a sculpture on the University of Chicago campus. It sits on the site where the nuclear chain reaction was uncovered and controlled, exactly at that site. The football stadium has been torn down, and some people, when they go up to it, it's huge, it's about 12 feet high. They say, oh, it looks like a mushroom cloud. Other people come up to it and they say, it looks to me like a human skull. When the sculptor, Henry Moore, the British sculptor, was asked, what did you want to say with this? He said, it's really a tribute, it's called nuclear energy, to the human spirit. And he said, and I think there's something cathedral-like because it has these openings with long Gothic windows. And that is the image I would like to have you have about this sculpture, because it is very cathedral-like, and I think it really summarizes a lot of Enrico Fermi, the Pope, who needs a cathedral. So thank you very much for your attention. We're happy to take questions.
Questions, please. Denise, please.
It's definitely not a technical question for me, but I was just wondering if the stomach cancer was the result of the research he did with the materials.
Let me take this. Okay. No, it was not. That is, his other collaborators, for instance, Rossetti lived to age 100, my uncle, etc. But more than that, we have a very good friend who was at the University of Chicago. He's an internist, and he checked with doctors who treated Fermi, and it was not the type of stomach cancer which is caused by radiation. So the answer is no.
Other questions? How about the process of writing the book in terms of what inspired you and the time it took and what's next?
Well, what inspired us was Enrico Fermi, and we gave some of our personal connections there, and the process was, it was intense. It was a lot of codependency in terms of my writing a chapter and Gino starting to go over it, or vice versa, or parts of chapters, so it went back and forth. And what's next, Gino?
I don't know.
We'd welcome suggestions.
Secrets, all authors have secrets. But it may well not be with the two of us, though we did have a good time.
Oh, very good. Well, how about your favorite Enrico Fermi story? Which of the things you learned or discovered, what do you think is the most remarkable thing about Enrico Fermi?
Well,
so
I think we each had a particular moving moment. You want to tell yours first?
So when we did our archival research, we were at Regenstein for many, many days. And, when you do archival research, it's dusty and musty, and you start sneezing, and you're wearing gloves. And Regenstein is very careful about the way they sign you in to the archives. And we, at least, were sitting in a room with all of these boxes that was enclosed by glass. And you could see the reception desk for the archives right outside. And at one point, I read Fermi's account of what had happened, which he wrote it as a report. And it was just this sort of clean and simple, and there was no drama in it at all about what had happened underneath that football field. And when I got to the end, I wasn't expecting this, but it was so powerful that way that I just burst into tears. So the receptionist came running in and with a box of Kleenex, which I thought was really lovely of her. And then she said, could you be careful? Could you back up a little bit? So Fermi brought me to tears.
And I'd say the most moving moment for me also occurred in an archive, but in the Pisa one. And it had to do, I have a copy of the collected works of Fermi, so I know all the works of the great physicist. But it was seeing his childhood notebooks. And, I was reading one there in Pisa, in the Domus Galileana, and you realized he's a genius already, there at 14 or 15. And it would be sort of like for a composer holding a childhood manuscript of Mozart or something. I mean, there's a little experiment he did of just measuring the height of the water in a lake. But he takes into account barometric pressure, he takes into account the humidity, the density, And then he has these careful graphs.
At age 14.
And he also has all the parameters, let's do a check of dimensional analysis of anything we say. And I realized somehow his brain was wired, in a sense, to make him the perfect physicist. And that was very moving to me.
He was trembling. I just saw my husband trembling.
I wasn't crying, but shaking a little bit.
We've got a question now, please.
When he came to the United States, left stock in the U.S., were there any repercussions out of Italy when they did not have him return to them?
I'm sorry, I didn't quite hear you.
When Fermi left Stockholm and went to the U.S. instead of returning to Italy, were there any repercussions out of Italy as a result of that against him or his family or extended family members?
He had wanted to do this quietly, and we didn't show it here, but we do have a picture of the New York Herald Tribune put it on their first page saying that he had escaped Italy and had come to the United States. They had, on January 4th, they had posted that story. It was not fake news. And he had partly one of the reasons that he was concerned about not having publicity was exactly the reason you mentioned in terms of he didn't want any repercussions on his family. There were so many things happening in Italy at that point. There weren't any serious repercussions. The people who were in trouble were already in trouble. His father-in-law did end up thinking that he had a letter from Mussolini praising him as a Navy admiral, but he was Jewish, and he did die in a concentration camp. So those things happened. I don't think there were any direct repercussions.
Yeah, his father-in-law died rather when Italy exited the war in September of 1943. The Germans then took over Italy, and in occupied Italy, then they began deportation of Jews. And that's when his father-in-law was taken and brought to Auschwitz.
Mike, please.
So you said Laura wasn't too thrilled about the U.S. So after Fermi's death, what did she do? Did she stay here or did she go back?
I'm so happy when people ask me questions about Laura. She became very much of an American. I think both Fermi and she love this country, and we're hugely grateful for this country sheltering them and allowing them to thrive here. And what was interesting about Laura Fermi is that during his life, she was very much in his shadow. He was the great man, and his kids were in his shadow too. But after he died, in some way, she became her own woman. And she went, shortly after he died, she was asked to cover an international peace conference about uses of atomic energy. And she went and did that and then wrote a pamphlet about it, and she became a peacenik. And as a matter of fact, this statue she did not love at all because she thought, well, Fermi, she wanted him associated with, okay, a nuclear chain reaction, but she didn't want him associated with the bomb. And she also became a major advocate. She headed up in Hyde Park. She stayed in Hyde Park, and she headed up a group of women who protested the burning of coal at the University of Chicago in terms of air quality. So this was in the 50s. This was pretty early. And then she also headed up a group against gun violence, again in the 50s. And she wrote several more books. So she had an amazing life herself after his death. And she stayed here the whole time. She stayed in Hyde Park.
Well, let's say thank you to Bettina and Gino. Really phenomenal.
Thank you.